Kcse Vision channel. Ijamarika, kindly subscribe, click the notification bell to get notified once I upload a new video. Today we are looking at the commonly tested questions in an exam, that is sulphur and some of its compounds in the contact process. But today I want to present using this diagram. So this diagram is showing the preparation of sulphur 6 oxide, where we have the sulphur oxide, and then we have oxygen. This one is passed through substance M. Then once the reaction has been takes place, whereby the sulphur oxide gas and oxygen now react, then we pass it through the substance K, and then we have the method of the gas collection, as you can see on this diagram. So what are some of the questions that you are supposed to expect from this kind of a diagram? Remember, sulphur 6 oxide is normally captured in the contact process, whereby it is used for in large-scale manufacture of sulfuric acid. So here we are supposed to name substances K and M. So name substances K and M. Substance M, and then we have substance K. We have sulphur oxide and oxygen. Once the gases react, they are passed through substance M to be dried. So M is just a drying agent, and this M is concentrated sulfuric acid. So you can have that this M, it is just a conch. So we name this one as the concentrated sulfuric acid. Why is the concentrated sulfuric acid here? It is normally used to dry the gas. Now we have substances K. In this substance K, normally once the sulphur oxide and oxygen react, they can react under the presence of a catalyst or some conditions. The conditions for a reaction of oxygen, a reaction of sulphur oxide and oxygen, conditions normally are, we must have a catalyst, and there are normally two catalysts which are used here. That is the vanadium hydroxide and the platinum asbestos as a catalyst. Of the two catalysts, the vanadium oxide is preferred to be used during the preparation of sulfuric acid in the contact process. And why is it vanadium hydroxide preferred? It is preferred because it is cheap and it is not poisonous compared to platinum asbestos. So in this case now, for that reaction to take place, they must take place in the presence of a catalyst, and that catalyst is vanadium hydroxide. There are other conditions like a temperature of 450 to 500, and also you can also talk of a pressure of 2 to 3 atmosphere. Those are normally the conditions required for a reaction of sulphur oxide to be converted to sulphur 6 oxide. But in this case now, you are supposed to name this substance K. The substance K, it is vanadium hydroxide as a catalyst. You can name also platinum asbestos, but the platinum asbestos is not commonly used because it is expensive and it is poisonous. So substance K, it is vanadium hydroxide, and substance M is concentrated sulfuric acid. State the function of substance M. The function of substance M is normally to dry the gas. So it is to dry the gases, and those gases are sulphur oxide and air, which is in this case oxygen. So we have sulphur oxide and oxygen, they pass through the concentrated sulfuric acid to be dried. So the purpose of this concentrated sulfuric acid is normally to dry the gases, that is sulphur oxide and air, which is oxygen. Now, given that the equation that occurs is, we have the equation which occurs is where we have sulphur 6 oxide combining with oxygen, sulphur oxide combining with oxygen, then we have sulphur 6 oxide, and then we have delta H, which is equivalent to negative 107 kilojoules. Want the information about the reactions provided by this delta H, which is equivalent to the negative 107 kilojoules. So the information provided here, it is just certain. The forward reaction is normally exothermic. So the forward reaction is exothermic, as you can see, as a forward reaction, the exothermic reaction, the heat energy given is denoted by the negative. So we have that negative showing that there is a lot of heat which is being generated, meaning that the forward reaction is just exothermic. Now, give the name of the method of gas collection shown on this diagram. You can see the methods of this gas collection. We have various methods of gas collection. We have those gases which are slightly soluble in water, like oxygen gas is normally collected over water because it is slightly soluble in water. We have other gases which are insoluble in water, like hydrogen. Hydrogen gas is normally collected in two methods. When the gas is dry, it's normally collected by the upward delivery because it is less denser than air. Then when the gas is wet, it is normally collected over water because the gas is insoluble in water. Other gases like carbon dioxide, dry carbon dioxide is normally collected by the downward delivery because the gas is more denser than air. Like ammonia gas, dry ammonia gas is normally collected by the upward delivery because the gas is less denser than air. Various methods used to collect the gas: use of a syringe when the gas is dry, like the carbon monoxide. The dry carbon monoxide is normally collected by the use of a syringe. Dry oxygen gas can also be collected by use of a syringe. We have other methods like the liquefaction method, and then we have also the freezing method. So in this case here, we have an ice here, and then we have the sulphur oxide. So this method of gas collection, methods of collecting this sulphur 6 oxide gas is normally freezing method. So the method used here is freezing method. Now, what important information is missing in this setup? As you can see in this setup, important information is missing here. I said that for the reaction of sulphur oxide and oxygen to react, it needs some conditions. A temperature of 450 to 500. Then we have a catalyst, of course, vanadium oxide, and then we have the platinum asbestos, and also you can talk of a pressure of 2 to 3 atmosphere. But in this case now, when we are measuring as you can see from the equation of the reaction, that during the reaction there is a lot of heat being generated, and as you can see here, the source of heat is normally missing. So the important information missing here in this experiment or in this diagram is normally the sources of heat. So you can talk of now heating solid in a combustion tube. So normally you can just say heating is normally missing in this reaction, in this experiment. So you can talk of in this case heat. Now we have that concentrated sulfuric acid is manufactured in large scale through the conductive process. Now, in that process, we are supposed to identify two substances that are recycled. What are the two substances which are normally recycled in the conductive process? In the conductive process, the two substances which are recycled, we have air, that is oxygen, and also you can talk of the sulphur oxide gas. So those are the two substances which are normally recycled. So we talk of oxygen gas here, which is air, and of course you talk of the sulphur oxide. Those are the substances that are recycled during the conductive process. And now, why recycling is necessary? Give two reasons. Recycling is necessary because it reduces the environmental pollution and also it reduces the cost, or it makes the process more economical by reducing the cost. So we are reducing the environmental pollution, and also you can talk of reducing, in this case, the reducing the cost. Now, sulphur oxide is a removed fat and scrapping in the conductive process. And then what is meant by scrapping? What is meant by scrapping? Normally, in the conductive process, we have gases of sulphur oxide or sulphur 6 oxide, which normally escapes in the atmosphere, to the atmosphere. The one those gases escapes into the atmosphere, they normally combine with rain, they form an acid rain. When it rains back on the earth, that acid rain, it has a severe effect on the environment, whereby it It can kill the aquatic animals, one source waters flowing to the lakes and rivers. It can also causes the cracking on the buildings. It can also causes what we call the stunted growth in plants. So the industries where the industries where the chicken where the industries where the process takes place, the chicken where the gases normally escapes into the atmosphere is lined with a substance of calcium hydroxide, which removes that sulfur oxide from the atmosphere by the process of, we call it scrubbing method. Now, what do we mean by this scrubbing method? Scrubbing method whereby we are saying is whereby it is the removal of acidic gases. So it is the removal of acidic gases by reacting with the paste. So it is the removal of acidic gases by reacting with the paste. The paste in this case we are talking about calcium hydroxide reacting with the acidic gas of sulfur oxide. It forms a substance of calcium sulfate which does not escape into the atmosphere, and also it can form water which can be used for domestic uses. Now, write a question to show sulfur oxide is scrubbed. So to showing these methods of scrubbing the gas, so we can also have sulfur oxide which react with the calcium hydroxide. So we have the calcium sulfate, and then we can have water. And also, if we will be required to state the importance of this scrubbing method, you can see now water is being produced here, and water has various uses. The equation shows a reaction taking place in the catalytic chamber. So in the catalytic chamber, we have sulfur oxide gas combining with oxygen, and then we have sulfur 6 oxide. We have the delta H, which is equal to be negative 197 kilojoules. How will the increase in temperature affect the production of sulfur oxide, sulfur 6 oxide? So increase in temperature, when you look at this kind of a reaction, the forward reaction is normally an exothermic reaction. When the forward reaction is exothermic reaction, increase in temperature, it favors a backward reaction. In this case, it favors an endothermic reaction. So in this case, if the temperature will be increased here, the backward reaction is favored, and therefore we will have a low yield of sulfur oxide gas. So in this case, now we say it lowers the yield of sulfur 6 oxide. Now, decrease in pressure. What is the effect of decrease in pressure in this sulfur 6 oxide gas? We know that increase in pressure, it favors the side which has the fewer molecules. For instance, now if we can talk of now here that the number of molecules we have, in this side here, we have 3 molecules, and on the other side we have the 2 molecules. So we have 3 molecules because we have 2 plus this one, we have 3, and then on this side we have 2. Increase in pressure, it favors a side which has a fewer molecules. In this case, if the temperature will be increased now, the forward reaction will be favored. That is an exothermic reaction will be favored, and if this side will be favored now, we can talk of there is an increase in the yield of the sulfur 6 oxide gas. So decrease in temperature increases the yield of sulfur oxide, and then decrease in pressure increases the yield of sulfur 6 oxide gas, and then we have increase in temperature decreases the yield of sulfur 6 oxide gas. Another common question that we will be asked here normally in this question we have, explain why the sulfur oxide is dissolved in a concentrated